Hi everyone, Roman Kozak here. Welcome to tutorial 2 in this 3-part video tutorial series, where we're learning how to design a printed circuit board using Altium Designer. Altium is the world's most popular PCB design software, and it's used at companies like Boeing and top institutions where engineering is taught. In video 1, we learned how to step-by-step do schematic capture and select the components and lay out the schematic for our portable battery charger. So we created 2 schematic sheets. One schematic sheet was focused around this lithium-ion, lithium polymer charge controller integrated circuit, and also had a USB input. And the other schematic sheet was focused around this DC to DC step-up converter, which took the voltage from the battery and steps it up to a solid and stable 5 volts with the help of some passives like that capacitor right there. We also took a look at the active BOM, which shows us which parts are suitable for volume production or which parts might go out of stock soon, so they wouldn't be reliable to work with. We also saw how much our board would cost at quantity 1,000, $7.42, and discovered that if we eliminate this component here, especially because we require 2 of them for our board, we could get our board cost down to $2.42. Anyways, so we left off in the last video right here. We finished everything with the schematic. And now we are on to laying out our board. Let me just go back here. In the last video, I forgot to put the designator here on this resistor. Here, this resistor is R6. Okay, the thing we're gonna do first is edit the board shape. And some shortcuts that are gonna be useful for you will be hitting the number 3 key on the keyboard goes to the 3D view. And you can go here and see the 3D view and the schematics that we have used in our schematic. And you can see the components here that we've used in our schematic. So we have the switch, the USB ports, the battery connector, etc. And if you hit the number 2 key on your keyboard, that's going to take us to the layout mode, and this is where we're going to lay out the copper traces to connect our components. And then finally, if you hit 1 on your keyboard, this is how we get to the board editor view. So let's go to design, edit board shape, and we're going to drag this down here so that it's in line with the origin. And we'll just make this a lot smaller as well. There's no point to have a big board. It's just going to cost more to manufacture, take up more space, and not look as nice. So I want my board height to be 800 mils. So take a look down here at the XYZ coordinates. So I'm going to move my mouse down until it's at 800 mils. So we're at 900, and it looks like we are at 800 mil. And I'll do the same on the right side, but I want to bring it over to 2450. So we're still dragging it over. 2460 actually. There we go. So this is our new board shape. We'll hit the number 2 on our keyboard to get back to the editor view for the components, and we'll drag these components closer. Now you can see our components are nicely separated. Here we have all the components that are in our step-up DC to DC converter sheet, and then here we have all of our components that are in our charge controller sheet. I want to do a few quick things before we start dragging our components over onto the board. We're going to click on this USB port here. You can see it's a USB port. And let me just reset the 3D view, top side. So we'll click on this USB port, and we're going to call this out. So this will be our output USB port that you'd connect to your phone, and this is our input USB port. It's just going to help us understand a little bit better what it is, we'll click on the switch. It's a power switch. And then this here is our battery connector, so we'll call that BAT. Finally, this LED here, we will call it CHG for charge. And this LED here, we will call it power. Okay, now let's take a look at quickly our reference board. So here it is, our reference board. I've already laid it out. So you can see I've placed the USB ports in the top left of the board, the power switch and the battery connector on the right. Here we have our DC to DC converter, and we know it's the DC to DC converter because it has the inductor there. It's common for a switching circuit, and it's input and output filter capacitors. And then here we have our charge controller with its input and output filter capacitors. And the way you lay out a board is actually pretty important. Some boards, it's very common for boards not to work if their components are not placed in the correct location. So, for example, capacitors and inductors generally have to be very close to power integrated circuits, especially our switching circuits here. But more on that later. We're going to start by placing the large components. So we'll go back over here to our schematic, and we'll place both USB ports. So just drag it over and click the space bar to rotate. And let's see, I put the input USB port on the left and the output on the right. So this is our output and this is our input. Also, I'm going to take these labels here. They're on the silk screen layer of the PCB. And I'm just going to move them and rotate them into a more visible position. And while we're here, we're going to change the text height to 30. Oh, 30. There we go. Now, next we're going to lay out the power switch and the battery connector. So let's drag over that battery connector and let's drag over the power switch, hitting the space bar to rotate it. And then we'll take the power label, put this at 30 mil, the battery label, 30 mil again. Let's take a quick look. Okay, we can see that our components here are highlighted in green. Now that means there are some issues. So if I click on one of these components that's highlighted in green, and I zoom in, let's just zoom in quickly. Okay, they're highlighted in green because the clearance between these two pads is setting off a warning in Altium. So that's going to be under design rules. And you just want to make sure that this is set from to 8 mils. I think standard in Altium it is 10 mils. So you want to set that to 8 mils, and you also want to click here, ignore pad-to-pad clearances within a footprint. So just make sure that is selected. Okay. Next, we're going to, it looks like we've laid out the major components. So we can start laying out some of the resistors and capacitors. So we'll start from the left of the board and work our way to the right. So R14 and R11, let's do those. So let's get R14 and R11. Okay. Okay, and just a quick comment about this. You can see that you can see these little yellow lines that are going from the pads of this resistor to the pads of the USB port here. And you can see the same one here. So the reason why we're placing R11 in this general region is because it will make the copper length not unnecessarily long. So we just want to place components that need to be connected together as close as they reasonably can be to each other to avoid very long copper wires running needlessly around the board. Okay, so we've placed R14 and R11 in their general locations. Now let's place R13, D2, and D1. Now this one here is actually R13. So I'm going to just go ahead and make sure that that is also fixed down here. So it looks like we mislabeled the designator here. So this here should be R13. Okay. And I also see that there is one resistor here that is missing a label. So that is a 4.7K, and I believe that is the resistor, yeah, that we missed earlier, so R6. So that resistor there is R6. So we could change that there. Okay. So we were going to drag over R13 as well as the two diodes. So D2, D1, D2, D1. Now let's space out these USB ports just a little bit more so that this resistor here can be horizontal. And you can see, clicking the spacebar allows us to rotate. I'm not going to place the resistor this way because then you'll see that these yellow nets here are crossed, signifying where they need to be connected. I'm going to rotate it like that so that I can imagine a nice copper trace going to the USB port there. D2, and then once again, nice and close to where it's expected to be connected. I'm going to highlight these three here and change to their text size to have a height of 30 mils. Okay, let's continue down the board. We have R12 and then 8, 10, 9, 7. So let's grab those. R12 and then 8, 10, 9, 7. Okay, here we go. And we will move the labels to the right of the board, of the component, sorry. And once again, we are going to decrease the text size here of the silk screen. Okay, let's see what else we have to connect. I'd say we've placed over 50% of the components, so that's really good. We have to do R3, R5, and R6. Okay, so let's do that. R3, R5, R6. Okay, and then I know we need to do the 2 LEDs. There we go, we have our 2 LEDs. And then we also need to do R4 and R1. So we'll do R4 and R1. R1. And while we're here, we'll just decrease the size of all of these label names here. Okay, that's a little neater. Okay, now we also have R2. Now, the reason I've left these components here to the end, and let me just bring them a little bit closer, is because they're the most important components to get right. Here I have my charge controller, and it's 2 filtering capacitors. So these capacitors need to be as close as possible to the input and output pins of this charge controller to enable it to operate in the correct fashion. Same with these 2 input and output capacitors, and especially this inductor here. They need to be as close as possible to the switching converter here. So I'm also going to right click here and just delete these rectangular items there, and then we can drag these all together onto the board. So I'm gonna place, oh, looks like something bad happened. It looks when I dragged those over initially, it also dragged the component there. So I'm just gonna, here I'm gonna right click and cut them, and then here, cut. Okay. Now we should be able to drag these over. Okay, so I'm gonna put these components here. We'll move the diode over, and you can see it's starting to get a little bit crowded. And a little bit crowded is good. It means we're not wasting space. Okay. So we'll just drag them over a little bit more. Okay. And we'll do the same with these guys. Okay, now we can take a look at the board in 3D again. And you can see it's really starting to take shape. All the components are on the board, which is good. And they're in the general locations that they should be. So right, I'm just now going to shift a few things around to make the space a little bit more efficient here. There we go. Now you can see the resistor was originally like this, And okay, that looks fine because I can see I can connect those two right there. So that's good. These four here, I'll try to keep in somewhat of a nice line. And you can see these two right here need to be connected together, so it'd be better to have them this way. As well, these two here will be connected together, D negative and D negative, so it'd be good to have them this way as well. Okay. And then we'll move these over as a group. We'll just decrease the label sizes on these. So just holding the shift key down as you select them. Okay. Now I just want to take a look here and see which way I placed these components. So with this guy here, I placed the designator at the bottom right, and this guy here I placed the designator at the top right. So let me just do that. Here, designator bottom right, that's that white dot, and then here designator top right. So when I previously laid out this board, I just found that is what works best. Okay, so you can see that right here on our DC to DC switching converter, this is the 5-volt output coming out of the DC to DC switching converter. Plus 5 volts there is the same plus 5 volts here. And we can actually take a look at the nets. So that 5 volts there is also connected to the USB output. So as you can see, that yellow wire here goes from the 5 volts of the switching converter, the output, to this filtering capacitor, which we want to keep nice and close to the IC. And then it goes here to the USB port. And I see R12 here is vertical, so I mean we could do that as well. And I'm not going to do the absolute most optimal way to lay this out. I'm just going to try to go pretty quickly. And then this is the capacitor that's going to be on the input of the DC to DC switching converter. So if I just exit out of that, that capacitor is right here, C3. Okay. So C3, and we're going to rotate this inductor so that it's as close as possible to these two leads. And you can see net C1 underscore 2 and net L1 underscore 2. We know we're going to be connecting those directly like that together. Okay. Now let's see. Here is the capacitor, C1, and let's see what C1 does exactly. So C1 is on the output. It's connected to the battery. It's on the output of our charge controller. But if you notice, C1 is also connected via this port to the input of our DC to DC step converter there. So we'll do something like that. Okay. Now I am going to try to move some of these components over. To give us a little bit more room to work with. Okay, let's take a look at our reference schematic again. And you can see this is the 5-volt input to our charge controller here. So this is coming from this should be coming from the battery. Yes. Okay. And let's see. This resistor here is for that LED. And then what resistor? Okay. And then this resistor here is for that LED. So R6 is for power, and then R1 here is for charge. Okay, I think we're just about ready to start adding the copper connections now that we have the components in a little bit more of the right place. So let's start by connecting our first component. To do that, we are going to click on interactive routing, and we'll select the component pad that we want to route. So we want to complete this yellow line here. So I'm going to click right here on the pad. And then as you can see, copper is being laid out. So I'm going to go up here, just like that. So we have successfully laid out our first copper connection. And you can see that yellow line has disappeared because yellow line just signifies that it needs to be laid out. Okay. Next, I am going to lay out this 5-volt connection here. So I'm going to connect these two, R11 to R14. So I'm going to click here, go to interactive routing, and I'm going to hit the tab button, and I'm going to select the width here to be 20 mils. Just because this is a power connection, so we want it to be slightly wider. Oh, and look, it looks like it didn't set it to 20, so we'll go to 20 here. So for some reason, that did not change to 20. Let's go 20. There we go. Now it's wider. And you will see here that if I go to Design, Rules, and I go to Routing, we had a width rule here that said if it has the power nets class, that it needs to be minimum width 20. And I'm just going to go to priorities here and make sure that this has the top priority, the power nets. There we go. Okay. Apply. Apply. Okay. There we go. So that error is now gone. Okay, now let's route this connection here. So CC1 in. So again, I'm going to click interactive routing. And there we go. We have routed that connection. We'll do the same with 5 volts here. But we're, as you can see, it wants to set the width to 20 because that's what we have in the rules. But then we are breaking another rule, which is making the clearance less than 8 mils between the two pads. So we will have to solve that. So as you can see here, the clearance is less than 8 mils, which is not good. So what we are going to do to solve that is we're actually going to start off by routing this with a smaller width. So let's try 10 mil. Okay, it's not allowing us to do 10 mil. Okay, so it was not allowing us to decrease the width of the trace here. So what we're going to have to do is go into rules, and we're just going to have to set the minimum to 5. Apply. So we still have our preferred width to 20, but now I've just made it so it doesn't throw an error if it's less than 20. So there we go. We can change this now to 10 without issue. There we go. Okay, without issue. There we go. And then we will connect these here. So interactive routing. Now let's see why we broke that rule. Okay, we might need to decrease this to 8 mil. There we go. Okay, we'll route this connection here. Okay, and now we're just going to continue. So Let's make sure that these are facing in the proper direction. Okay. So we're going to set that to 20 because it is our preferred width for power traces. And then we'll also route that power trace. And then again, we'll connect these pesky ones inside using the 8mm. I realize that I want to switch the locations of these two resistors here. So I would like to go to Routing, Unroute Connection, and click on these two connections. And then that's going to remove that trace that was laid. And then now I should be able to simply drag these components into their new places. This is going to make it slightly easier to lay out these components. Okay, let's add that. Let's route that 5-volt track again. There we go. And then we can route this 5-volt track. Then there we go. Okay, and then next I'm going to connect D negative and D positive. So I can see I have D negative and D positive here. So let's connect these. Oh. So I'm going to go to Route, Unroute. And then I can go up here. Oh, that's D negative there. Okay, so next we're going to route D negative and D positive here. So I'm going to start these both off on the bottom layer. Okay. And then we're just going to go to approximately the location of where they are on the top layer. And then I'm going to change it from the bottom to the top. And then it's going to place a via. And then there we go. We can finish the connection on the top layer. Likewise with D negative here. Maybe we can go up this way. No, it doesn't look like it. So I'm going to start on the bottom layer. Follow D positive. Up here to the top of the board. And then we're going to select to go to the top layer. And then there we go. We can connect D negative. Okay, so let's route this pin as well here. This one's going to be just a little bit tricky. Okay, so we've routed D positive there. And then we will do the same with D negative. And let's just confirm that we cannot go diagonally. Yeah, no, that's not enough clearance to do that. So what I will do here is go on an angle like that, and we're going to need to shift this trace over. Just like that. And then looks like we'll need to shift this capacitor down, this trace down. Okay, now we can put a via here, so I'm just going to continue routing, and we'll select the bottom layer. So we'll select to go to the bottom layer, place a via there, and now we're back on the bottom layer, and we can go over to D negative. So we'll just go around D positive, and there we go. We can connect to D negative just like that. It's a little bit messy and definitely not ideal, but it works. Now to connect to 5 volts, I'm going to go on the bottom layer from one of these pins here. So we'll select routing. We'll here select the bottom layer. Looks like we're going to have to shift a few more things around here to make that work. Okay, bottom layer, 5 volts. And there we go, we can connect it with the via. So I'll have to click top layer, via to positive 5 volts, just like that. And we can go ahead and try to make this trace bigger. There we go. And we'll select this to 20 mil. There we go. Okay, we still have quite a few things to lay out here. Including, we do have to connect this 5-volt pin to another 5-volt pin. So I think we're going to do that with a via. We'll start on the top layer, and then we'll select here the bottom layer. It's going to want to place a via, so we can do that there, and we'll have to just shift this around. And then we should be able to pick up routing from the bottom layer and connect these two like that. But we'll change the width here to 20. This is a little bit Frankenstein, but it's just so you get the idea of how routing works in principle. Okay, we have a good portion of things connected on the left-hand side here. Let's make our way to the right. We can connect the resistors for the LEDs. Okay, so let's route this connection. And we will route this connection here. And we're just going to continue on with some routing. And if we click Control while clicking on a pad, we can see where it needs to be attached to. So this guy here needs to be connected all the way over there to the left. Right click, clear filters. Now, the way that these two ICs, like I said before, need to be laid out is quite specific. So we can tackle that now. Okay, let's continue routing. So we go interactive routing and connect these two. But once again, it's not liking the thick trace width, so we will change that to 10 mils. Okay, now let's connect the inductor. So let's change this to 20 mils. Let's see if that causes problem. No, it does not. 20. Okay, 20 mils, sorry, does cause problems. So what we're going to do is we're going to keep that at 10 mils. Or you know what? We'll start from the other side. We'll start from the inductor side with 20 mils. And we'll go as close as we can to the pad without setting off the clearance restraints. So we'll go right there, click, and then we'll decrease to 10 mil. There we go, to make the final connection. And we'll do the same on the other side. So we will start with 20 mils, get as close as we can, and then change this to 10 mils. Perfect. So this here is a resistor, and we can simply route it this way. Just like that. Okay, now the majority of this part here is done. I guess we could route this resistor like that. Okay. And 5 volts, I suppose, like so. And bring 5 volts over this way as well. Okay. Okay, so it only looks like there are ground connections left there. That's good. Now, before we route this charge controller, I want to make note of its data sheet. So in the charge controller data sheet here, if I do control left layout, you can see it has some very specific layout recommendations. So it's recommending to have a top and bottom polygon with vias on the pads here. So, I mean, we will follow its typical layout like that. So this here is 5 volts in. So we will go to the polygon tool, polygon pour, and we can draw a polygon. Oh, we'll just exit out of that. Okay, let's try that again. Let's click polygon pour. Okay. And then we're going to do the same with the VBAT pin and the C-out capacitor. Okay, let me just redraw that polygon there. Okay, so we're going to go back to drawing a polygon. And this one here is going to connect this pad to the capacitor there, okay? And that one there to ground, okay. Good. Okay. Now we're also going to go to the bottom layer and just redraw that polygon on the bottom layer. So we can just retrace it like so. But this time, if we take a look, it is on the bottom layer. And we'll do the same here. We'll make sure that it's drawn on the bottom layer. And we're going to give it the net name 5VN. So 5VN here. Okay. Bottom layer. And this one is going to be net C1_2. Okay, I'm going to click repour. Net C1_2. Okay, good. net C1 underscore 2. Go to top layer, and we're going to drag that polygon over. And then select repour. Perfect. And we're just going to make sure that this bottom polygon here is 5 VN. Perfect. Repour. Looks good. Okay, now we're just going to add a couple vias here. So 1 via, 2 via, 3 via. And we're going to make sure that they have the proper net names. And then we'll go here again to the polygon. There we go, select repour. And now you can see it's connected to the vias on the top. And connected to the vias on the bottom as well. Okay, and we're going to just do the same quickly for this polygon as well. So we'll go 1, 2, 3, 4. Perfect. Okay. So we have added a very rough ground plane here. That should suffice. And now you know how to do it with polygons. Sorry, not ground planes. We added just polygon planes here. And now we're going to connect these two here. Perfect. And we'll connect the 5-volt in from this resistor to this polygon plane. And we can do that using a via. So we'll switch to the bottom layer. It's going to place a via. And then we should be able to just simply go over it like that. Perfect. Okay, just a few more things to route. Yes, these power connections here are pretty important, so we're going to do them next. And I'm actually going to use route, unroute this connection here, because it's not an important connection at all. What is an important connection is this here. So we will just make sure it's routed first. Okay. And then we can route this LED. So we could go around something like that. Again, very not ideal, but it works. Okay, not too many other connections to do. So we need to connect this LED pin over here. So I'm probably going to do that just with a via to make my life easier. So I'm going to start routing this on the top plane. I'll go to the bottom. And then we will add in another via to bring us to the top plane. Okay. Now let's see if we have any non-grounds that remain. Okay, we do have one, and that's here. It's from 5-volt in to the USB here. So 5V in. Okay, and that's actually a pretty easy one. So we're going to go like this. Bring it all the way over. Just like that. Okay, that's finished. And nope, we forgot to have that as 5V in. And then we can re-pour that. Okay, we have managed to wire just about everything together. I'm going to save this project. And then we're going to finally connect all the grounds together. And one of the easiest ways to do that is just to create a polygon over the entire top and the entire bottom of the board, and assign the polygon to the net ground. So that's what we'll do. We'll go like this, and we'll assign that polygon ground. Okay. Good. Click enter. And then we're going to go to the bottom layer and do the exact same on the bottom layer. So we're going to grab another polygon, make sure it's the bottom layer selected, the net is ground, and then we can lay that out on ground. Just like that. Perfect. Okay. Now select repour. Now I'm also going to go to design here and rules and click on plane. Let's take a look under polygon collect. I'm going to select direct connect, apply. And then click OK. Okay, click on that top polygon again and just make sure that it's set to ground. And then we want to repour it. And that should make all these little errors go away. Okay, so we can see that it was connected there, there. Let's just go to the bottom layer again and make sure that the bottom polygon is set to ground. Okay. We'll repour that one. I'm going to double click on this top one. Pour. Okay, I think almost all connections have been made, except for these two. And that we should be able to fix that just by putting a via in here. Yeah, there we go. Okay, two more things. We did forget to route that connection there, so that's quite easy to do. And I'll just make sure to repour that. Perfect. Okay, now let's take a look at what the issue is here. Just not enough clearance. Or maybe we can perfect. Okay, that issue is solved. I see no other issues on the board. Okay, now let's take a look at the 3D view. 3D view controls, top side. Okay, there we go. We have fully laid out the board and we have routed all the connections. Not in the best way, but at least you get the general idea here. I'm just going to add a few more things. So I'm going to go to place, graphics. We can add a nice little logo here. So I'll go to my desktop logo. Sure. And you know what? But we need to actually make sure it's on the right layer. So let's go here and put it on the top layer. And then we can go place, graphics, and we'll do that again. Logo. There we go. Now it's on the proper layer. And we can add even some text here that says USB-C charger. Okay. So this is it. This is our board. It's fully laid out, and we solved for all the errors. I'm just going to save this board and commit the changes so that we can keep track of it in version control. So in order to do that, I'm just going to click File, Save, and then go here and save again. Oh, and it just looks like I'm not connected to the internet, so let me fix that real quick. Okay, we've fully finished placing all our components on the PCB as well as routing the connections between them. So now I'm just gonna click Save to Server and add a commit message that says finished PCB layout. And add a little exclamation mark there as well. Click OK. Now it's committing these changes to version control so that we can go back anytime and see what changes we made. So that's it. We're finished laying out our board, and in the next video, we're going to generate the manufacturing files, and then we will go ahead and order this board from a Chinese manufacturer called JLC PCB. It's very cheap. Hopefully it can cost under $10, and then we'll get this board in about a month, and we'll be able to assemble it by hand. So thanks so much for sticking with me throughout this second tutorial, and I'm excited to see you in the third and final tutorial next.